Let's see how to connect Modbus device on KMS.
We have one PLC connected to KMS over LAN. The IP address of PLC is 192.168.2.80 and port number is 5002. Some predefined simulated value are running on PLC holding registers starting from 40120 onwards.
To start, log into the platform using your login credentials. Once logged in, if you have admin access, you will be directed to the complete landing page with all available widgets. From the menu, go to Communication and select Modbus. Here, you can view all the connected Modbus devices. To add a new device, click on the Add button. Enter the following details: ETL name, logical name for the device, IP address, 192.168.2.80, port number, i.e. 502. Once the device is connected, create a group name, which works like a folder to organize your devices. Assign a logical name such as Machine 1, Machine 2, or simply Group 1, Group 2. After entering the group, configure the Modbus parameters. Device ID, unique identifier of the Modbus device. Register address, the starting address to read from. Function code, FC3, read holding register, or FC4, read input register. Number of registers, specify how many registers you want to read. Then click Add Tags. Once the Modbus parameters are saved, the list of configured rows will be displayed in a table view. Now, define the tags for each parameter to map the data meaningfully. Tag 1, voltage, data type float. Tag 2, current, data type float. Tag 3, kilowatts, data type float. Before proceeding further, preview the real-time values for verification. To do this, click on the I button next to the tag and ensure that the live data is being read correctly. You can also configure whether each tag should be stored in the database or not, depending on your requirement. In addition, you have the option to apply dynamic contextualization, which allows you to enrich the data with meaningful context before storing or using it. Furthermore, the platform provides a writeback facility into the PLC, enabling you not only to read data, but also to send control commands or update values directly to the connected devices when required. Now, you can define static contextualization for your data, which is particularly helpful when building dashboards and applying filters. With static contextualization, you can segregate data based on fixed categories such as area, line, or machine. For example, assign Machine 1 for the first set of values. Assign Machine 2 for the second set of values. This structured tagging ensures that when you visualize the data on dashboards, you can easily filter and analyze it by machine, area, or any other defined category. You can also pre-process the data coming from the device by applying arithmetic expressions before storing it or using it further. This allows you to normalize or scale the raw values as per your requirement. For example, if the kilowatt value needs to be divided by 10 before entering into the database, you can define this rule directly in the configuration. This ensures that the data is accurate, meaningful, and ready for analytics without requiring extra manual corrections later.